huge.
So, three dimensionals.
Three.
What have we been working in? 2D, right? So if it's 3D, it's what?
Three-dimensional.
Yeah, so what's that mean?
I think it's like actually here. It's like
You can see the depth.
Okay, you can see the depth.
You can
So,
see- it's like a
here's a
depth.
question. If you think about, we've been doing a lot of two-dimensional things on a coordinate plane, right? So, where would I, don't say anything out loud, let everybody think for a second. Where would I get my third dimension on my coordinate plane? Where is there another axis, in other words? Ooh. Everybody have an idea of what you would say?
yeah,
No.
yeah. I learned this. Toby,
No idea.
What?
That class told me. I think
What?
Z.
The z-axis. Perfect. And where is it?
Oh, going through the middle of the shape.
It's like
Inside
The
of the shape.
z-axis would be is if I could have a really sharp end on this and stick it into the center and push it through the wall, the z-axis would stick out the backside, but stick out in front. So my 3 dimension is the depth, like you said, and it is called the z-axis.
How's that work?
How's that work? What do you mean? So then, basically, I always, in my geometry class, use a Kleenex box as an example, right? So now there's
Can you
a
stab it?
length, there's a height, and there's a width, right? So the part that sticks out is that z-axis.
I thought you were talking about graphing it.
You could graph it,
But how would you do that with the z-axis?
well, so, like if this was my box, I would shove it through the wall. The part that's sticking out would be the z-axis. And then the x would still be here and the y would still be here. The z would be how much it sticks out. Okay? So, from here then we have a bunch of vocabulary today. So I know you guys don't usually associate vocabulary with math, but especially in like geometry, we do a lot of vocabulary. Okay, so what's a plane in math?
coordinate, like graph, like an area where.
Okay, that's one way that you could say it, but no. Not a coordinate plane, just a regular plane.
Field. I don't know.
A plane is simply a flat surface.
Oh, like
Oh yeah, like an actual plane.
Okay, so what's a flat surface? It's a flat surface that also realistically extends
everywhere.
in all 4 directions. So if you think about a plane as being a rectangle, then it's going to go in all 4 directions. So essentially it goes in every single direction, right? So a plane could be the floor. The plane could be the board. The plane could be the ceiling. Anything can realistically be a plane. Your piece of paper is a plane. Okay?
If there's dirt outside, dude, plane.
Sure. All right. So from there, then, planes, if we put them together, form polyhedrons. Okay?
Is it like polygrams but dragons or something?
Hey, enough with the comments. Unless it's a serious one. There's not going to be any dragons today. So, this is going to be a solid figure. With flat surfaces. So again, my Kleenex box would be a polyhedron. All right? That encloses space. What's space? Space is just space, right? Kind of the air that we're talking about. When we talk about these flat surfaces now, each flat surface is a face. So they're gonna ask you to name the faces. Faces are again flat shapes. And this can be any polygon. What's a polygon again?
Side shape with closed sides and, it is
Straight lines, right? Okay? Gotta have a straight line, it's gotta be enclosed. Most of the time when we talk about faces being polygons, they're either going to be a parallelogram, more specifically a rectangle, or they're gonna be triangles. Okay? From there then, we look at, we introduce the word an edge. What's an edge on my Kleenex box again? Where would an edge be?
The corner.
vertices.
But an edge has to be where two what come together?
Two vertices.
Two faces.
Two faces, right? So an edge is where two faces come together or meet. And then where two edges meet at a what? So where do my edges meet? This and this meet at, now what were we pointing at? Vertex. Perfect. Two edges meet at a vertex, which essentially is a what? Essentially a corner or a point. So we can name it as a point. So, again, this is an important word, this is an important word, and my face is an important word. Which leads us to a prism. What's a prism?
Like a thing that reflects light that,
Different kind of prism.
oh,
What'd you say, Kendall?
3D shape.
Would you consider this a prism?
Yeah.
If I
Rectangle.
put this back on? Okay. So what in general happens in a prism?
They
Okay.
usually have a square at the bottom.
They do?
Yeah, a square and rectangle.
They have to?
No.
So a prism is going to be shape, yeah. Or we could say a polyhedron. A polyhedron with congruent, parallel, oh, can't spell. Faces. So, what's this word meaning in?
They're the same size, same shape, same everything.
They're exactly the same. What's this shape mean?
They don't touch. Never
They don't touch. Okay? They have the same slope.
They're kind
But
of-
now we're talking about faces, right? So here, would you consider that there's congruent faces that are parallel to each other?
Yeah.
Where would you say they are? The top and the bottom. Is there any others? Left and right. Right over there, right?
The other left and right.
The other left and
Or
right.
I mean,
And then front and back.
yeah, that's what I mean.
Exactly right. Okay? So, here we go. The parallel faces have a special name. One set of parallel faces is called the bases. So this is where it gets confusing with a, what did you call this? What kind of prism? A rectangular prism, right? So when you look at this right here, what would you consider the base?
Bottom.
The bottom.
Where it's sitting on?
Yeah.
Okay? So if the base is the bottom that you're considering just because it's sitting on it, then the other base is the top. It's the one that is parallel and congruent to that. Okay? Does anybody else see it a different way? That's okay. Somebody said the sides earlier, right? You could always say that these are the bases of a rectangular prism too. Okay? Notice that this one right here and this one right here would still be exactly congruent and would be parallel to each other. Right?
Could you use two different kinds of,
Exactly right. So if this Kleenex box would have a different shape besides a rectangle as its base, it has to be that shape then for the base. So if this right here, this side right here was a pentagon, for instance, then this side right here would be a pentagon and this side right here would be a pentagon. Those have to represent the base and not the faces. In this one, because they're all rectangles, right? No matter which way we look at it, you can actually say that any of the groups are the base. But most of the time, people say the top and the bottom are the base because it's sitting on the base. See what I'm saying there? But it could be any shape that we wanted. All right? So when we talk about a base, the base can be any polygon again. And is how you name it. So again, if I had a pentagon as my base, right? Then it would be called a pentagonal prism. If they're octagons, it would be an octagonal prism. So we name it by the base, and all the other sides are going to be going back and called faces. Okay, so we name it by the end, but then all the other sides are faces, which we've already introduced. And in prisms, all my faces are, I'm going to use this word, which I probably shouldn't, rectangles. And I'm going to put parallelograms below it. We should really say parallelograms, but most of the time we're going to realistically write them as rectangles. So notice, again, it doesn't matter which one you decided was the base, right? Everybody said the top and the bottom. Notice that everything else is a rectangle, right? Okay, so if I would try to draw this, and these are kind of hard to draw, try to draw a pentagon.
doesn't matter, it's regular.
Just make a vanishing point.
Just make a pentagon. It doesn't matter. And then try to draw another pentagon up to the right that looks like your first one. I don't know what mine look like. So there's my two pentagons. And then how do I draw the rest of it? I'm just going to connect vertices. But notice, when I connect my vertices, what is this shape right here? Those are all rectangles or parallelograms. So in this case right here, every single time that you have a prism, you look at if there's a different shape, that has to be the basis. Even though it's not sitting on it, this is still a pentagonal prism because there's a pentagon in them, and there's rectangles then in between them. So not only are all the other sides called the faces, these are actually called lateral faces. I don't think we get into as much with lateral versus non-lateral faces in this particular chapter, but we would in geometry. Okay?
Would all shapes have two more faces than they have sides?
Two more bases.
Faces than they have sides.
In the sense, if you consider the bases a face too. Right? Yep. So again, that's where a rectangular prism gets a little kind of sketchy because you don't know which one's the base. And you could realistically call any of them the base. Because we'd have rectangles on the other face. Okay? Questions with any of that? So what's the difference between a prism and a pyramid?
A pyramid does not have,
A pyramid has two shapes.
Okay? So next we're going to introduce a pyramid. And the main difference is what you say?
They don't have parallel faces.
They don't have parallel faces. Perfect. What else?
The base is a square.
Does it have to be a square?
No.
Nope. So, how many bases do I have? Exactly right. So in a pyramid has only one base. And again, the base is any polygon. So Grace wanted to have a square there. But again, it could be a pentagonal pyramid, right? We don't have to have a square. It could be any shape that it wants. The faces are what in a pyramid? What shape are my faces? The faces are all triangles. And they come together. They meet at what? The vertex. The vertex is a point. Forgot me. R. So again, try to draw a. We'll use a pentagon again. Draw a pentagon. Okay. Then draw a triangle from what I would call the outside points, and then from the top, connect it back to every other vertex. Okay. So it looks a little weird because my pentagon wasn't drawn very good. It's not a, what kind of pentagon? A regular one. A regular whatever makes my pyramid and my prism look what I would call pretty, right? But, so, this is my point up here, which is my vertex, the very top, and then all of my triangles. Now, in this shape right here, and in this shape, my prism and my pyramid, why is there dashed lines? You can't really see them, right? They're on the back side of it. So if I showed you the whole thing, you couldn't see those ones, but you got to realize that they're still there. So we draw them with dashed lines instead. Okay? And then the last thing that we want to talk about, we've already mentioned diagonals before, haven't we? What's a diagonal in a polygon? If I asked you to draw a pentagon again, what are the diagonals of that pentagon? They connect. It's some segment that you can draw from a vertex that goes to every non-consecutive vertex. Right? Non-consecutive means I skip over this one because these two would be consecutive. All right? So this would be a diagonal here. The last thing that they introduce in this is an interesting concept. So I want you to try to draw your rectangular prism. So draw a rectangular prism on your paper. One that looks like your my Kleenex box. So basically, you could call it a square prism if you wanted. Again, the square prism gets me a little easier, as long as I can draw a square. Probably definitely a rectangle more than a square though. Right? And then I'm just going to connect my vertices. Okay. So the next concept that they want to introduce is something called a skew line. I'm sure a lot of you will like this word because it's just kind of weird to say, right? So what's the word skew mean? A skewer, right? You would stick in or stick your meat on and grill it. But what's a skew line? So if I would tell you that a skew line or skew lines to each other will never touch. If I would write that, what would that bring to mind to you? Parallel lines, right? So what if I would tell you skew lines will never touch, but are not parallel to each other? What do you think about that? So let's go back up here and start naming this thing. Let's say, put the letters in the same spot. A, B, C, D, E, F, G, and H. But put your letters in the same spot so we're talking about the same thing on your paper as we're talking on the board. So can you come up with something that would be considered skew lines? Now they're not truly lines because they don't go on into infinity because we have a figure. So they really should call it a skew segment, but we'll let it pass. That will never touch each other, but would be considered not parallel to each other. C, D, and what?
GF.
Perfect. Aurora says C, D, and GF. See how this one right here kind of goes left and right? This one on my box goes up and down. Are they parallel to each other? Obviously not, because they're going in opposite directions, right? But will that line ever touch that line? No, because they're separated apart from each other. So that's what makes them skew. So here's a question. Can I have skew, in this case right here, could I have skew planes?
Yes.
Could I have this plane on the bottom, A, B, E, F? See what I'm talking about? Is there a plane that will never touch that one? In this case, it doesn't work out, right? This one touches it, this one, this one, this one, the back one does. And the top one would be what to this one? It'd be parallel to it. So we don't have a skew plane, but we have skew segments. Okay? What's another example of skew segments?
H, C, G.
H, C, and GF. What'd you say, kiddo? H, E, and A what? A, B would work.
Would D, G, and AB work?
D, G, and A, B would work. Yep. So essentially they got to be kind of separated by something, right? They got to be separated. Okay? So turn your book to page 559. So we'll stop making you draw all these things and look at the book. So on page 559, we want to look at number 3. So in number three, what would I call that solid? A what kind of pyramid? A triangular one. There's all triangles, right? So then the base has to be a triangle too. So in this case, what would you consider the base? Okay, don't forget your symbol. So write triangle, RST. So if you consider that the base, what's the face? Or faces? Give me one face. RQS. Give me another one. QST and the third one. TQR. Exactly right. Give me one edge. Okay? ST, RT. Any others? TQ. QR. Right? That would be all of them. So in number 4, what would you consider the base? You would consider it, say it one more time. BF, EF, GH. So you're saying the bottom. Anybody else? Oh, so if Addie says EF, GH is the base, what else has to be the base? A, B, C, D, right? Okay, so if that's the case, what are the faces? B, C, G, H would be one. A, D, E, F would be one. A, B, E, H.
D, C, F, G.
Yes. Okay, so the last two. This is being really picky. Alex said D, C, F, G, I think. Make sure you go around basically in a circle to name it. So he should say D, C, G, F. Don't go across the diagonal and then back. That makes sense what I'm saying there? Okay. Number 5. Would you consider MP and TM parallel, skew, or intersecting? Because they do what? They touch. Perfect. What would you say is skew to PO? Is there anything that is skewed to PO? MS would work. And MT. Perfect. Make sense? All right. So, questions with this? All right. I lied to you. I said it was only, you were going to have 20 minutes. You only have 10 minutes. Sorry, Grace. Number 1, don't skip. It's worth 20 points.
What?
Number 10.
Oh, that's.
So make sure you look at what it says up here. Number 10, you have to follow the directions. It says identify the solid, name the bases, faces, edges, and vertices. That's why it's worth 20 points. Number 11 and 12, what's it say up there? Just name it. I want you to tell me what it is called. You don't have to do the rest of it. Does that make sense? Follow the directions.